let's take another sort of digression here that we did with one-way ANOVA and talk about how to get these things as a computational approach. So instead of thinking about marginal means, cell means, we're going to think about marginal totals and cell totals. So marginal totals, we look in the margins of the data set when computing main effects. We're actually going to just add them up and get a total, a sum. Same thing, instead of getting a cell mean, we look at the cell totals when computing interactions, so we're just going to sum those up. In order to use the computational formulas, we need to compute both marginal and cell totals. So instead of having the table where we rearrange everything in terms of means and standard deviations, we're going to rearrange everything in terms of sums. We'll add up the values in different ways. Okay. So here is our data set rearranged in terms of sums. So when we added up the first three were like 0, 1, 0. If you look back at back here, the first three were 0, 1, 0. You add them up, you get 1. The next three are 5, 7, and 6. All right, so 5 and 7 is 12, 6 is 18. Okay, that's where that number comes from, 18. We're going to add up those three to get 19. We're going to keep doing this. We have each of the cell sums, and then we can also just sum across. So 19 plus 1 is 20, plus 18 is 38. We can then sum these, right? Sum everything. So we can actually have marginal sums for the B's, and I can have marginal sums for the A's here as well. You can also sum all 27 scores to get the total. All right, this is sum y. The total is 152. And then if I were to go back to here and say I want 0 squared, 1 squared, 0 squared, 5 squared, 7 squared, 6 squared, square every single individual score and add up all 27 of those squared values, I would get this sum of y squared, which is 1046. So normally when you're looking at the computational values, these are the things you want to see as sums, you want to see a total, and you also really want to see that sum of y squared there, because if it's not there, you got to go through and manually square everything to get that number. So here are these the computational equations, and you probably see some parallels, or at least some familiarity with the versions from the one-way ANOVA. But just to sort of walk through these and talk about what each part is and why there's like double sums and all this stuff. So the sum inside of the parentheses says sum AJ. So go back a second. All right, so sum A1. So where do I get the sum of A1? So here's A1 right here. If I take A1 all the way across and I sum it, I get a sum for A1, which is 37. So I'm going to sum A1. And then the equation says I'm going to sum A1, and then I'm going to square it. And then I'm going to sum A2. I'm going to square that. I'm going to sum A3 and square that. And once I have those squared sums, I'm going to add those together, which is why there's a second sum. Okay, so I'm going to sum up all those sums. But I got to square them first. So I'm going to sum up all the squared sums. And the A, B, and N here refer to the same thing they did before, which is the levels. So like this is B in our case has 3, so it's 3. N has also 3, so 3 times 3 here is we're dividing by 9. And typically what happens is we're adding up 9 things to say get A1, so I'm going to divide by 9 here. Total, I'm adding up 27 things, so that's why I'm going to be dividing by 3 times 3 times 3, which is 27. All right, so here we get the total, which is still pretty self-explanatory. This is the same thing as big N, capital N. Here we got the sum of each BK, so B1, B2, B3. I'm going to sum up each one of those. I'm going to sum up B1, which is 38. I'm going to square it. I'm going to sum up B2, 62. I'm going to square it. I'm going to sum up B3, which is 52, and I'm going to square it. Then I'm going to add up those 3 squared sums. Okay, and then I'm going to, again, subtract, divide by A times N, which is also 3 times 3 in this case. Total squared over ABN, same thing. Here I'm going to sum all A, J, B, K combinations. All right, so go back again. I want to sum up I want to take 1 squared. That's A1B1. 18, which is A2B1 squared. 19 squared. 17 squared. 18 squared. 27 squared. 19 squared. 25 squared. 8 squared. And I'm going to add up all of those squared sums. Okay, that's what this is saying here. And then what's left on the bottom is just n. So we're dividing that by 3. And then I already found this component here, which appears there again. I already found this component, which appears here. And then t squared over abn appears there again. And then once I find this sum of aj bk squared and summed this thing, this component disappears back here again. The sum of y squared is a value that was given in the table on the last line. So we end up having sort of everything else already done. Now, what's nice again about this, why this sort of helps to go a little faster, is that these pieces get recycled as the equations go on. When we get down to the last few of them, there's very little to actually compute. Let's look at how this is done. There's a lot of stuff here, so we'll go through little by little. So the first one, sum of squares for a, I get the sum of aj squared over bn minus t squared over abn. All right, so I got some sums of a that I need to do. Sum of a1, sum of a2, sum of a3. All right, so I need the sum of a1. So the sum of a1 over here is 37. So this is going to be 37 squared. And then the next one's 61. So I need a 61 squared there. And the next one is 54 squared. 54 squared, and it's bn on the bottom here. So that's simply b is 3 levels, n is 3 levels, so that's just 9. The total we have here, 152. So 152 squared over, and then a is 3, b is also 3, and then n is also 3. All right, so let's work that out. And it's best to sort of work these out as you go, because you see the parts get recycled. So let's look at the first part. The first part is, all right, it's 37 squared plus 61 squared plus 54 squared equals, it's about a little over 8,000, 8,006. I divide that by 9. So I divide that by 9, which gives me 889.556. Okay, so write that here. So this ends up being 889.556. Okay, 889.556. Okay, give myself enough room there. And then I need to figure out the t squared over abn. So that one's a little easier. It's just 152 squared, which is 23,104, divided by 27, which is 855.704. All right, so this ends up being, I'll just write it up here. So I'm going to subtract then 855.704. All right, so if I did it right, 889.556 minus 889.556 minus 855.704 equals 33.852. All right, so it's 33.852 even if you want to go that far, okay? Great, that worked out. Matches the deviation approach. So let's do the same thing for B. Okay, so I know this part is the same thing as the total squared. I don't need to do this again. I already did it up here. I already know that this is, let's see if I can write it smaller, 855.704. I already knew that, so I don't need to do it again. So I need to figure out what it is for B. So for B, I got this 38, 62, and 52. Those are my sums. So I need to take 38, squared plus 62 squared plus 52 squared. That. And still, we divide by an. A is also 3, and is still 3, so it works out. It's all 3 times 3 is also 9. Okay, so 38 squared plus 62 squared plus 52 squared equals 7,992 divided by 9 equals 888. So this is exactly 888. So let's see, 888 minus 855.704 equals 32.296. All right, so this is, instead of thinking that's 32.30, this is 32.296, which is basically 32.3. Okay, so great, that worked. Now what about this crazy long one? What's going on here? So I need the sum of all A, J, B, K. So every single cell sum I'm going to put in here. All right, so let's start back over here at the very beginning. I need to go 1, 18, 19. All right, so this is 1, this is 18, and 19. Okay, 17, 18, 27, 17, 18, 27. Wow, there's 2 squares there. It's not supposed to be like that, so let's get, this is not supposed to be here. Okay, 27 squared. And then I got 19, 25, 8. 19, 25, and 8. That. And we have n on the bottom, right here. So n's just 3, so divide that by 3. And then what am I subtracting out? I'm subtracting out this sum of the sum of AJ squared. Well, I already did that, so I don't need to do this part either. And I'm subtracting out the sum of the sum of BK squared. So I don't need to do that part either, because I already figured it out. I'm adding back in a T squared over ABN, just here, right? I also found that, so I don't need to do this either. All these parts have already been sort of done. So I know that if I'm taking whatever this is, I'm going to subtract out the sum of this sum of squares for A, which is 33.852. Okay. So all right. So this is 33. No, not 33. Sorry, that's the sum of squares. I actually need the part here, the 889.556. Which again, I didn't give myself quite enough room. 889. All right. Let's see. 889.556. All right, that sort of fits. And then for B, it's 888. That goes here. 888. And then I'm going to add back that 855.704. 855.704. Oops, let's scoot that over a little bit. Here, 855.704. Okay. So all you need to do is figure out this first part, which I get from this part here. So let's do that. So I'm going to do, back to my calculator here. I need 1 squared. All right, big shock. Plus 18 squared plus 19 squared plus 17 squared plus 18 squared plus 27 squared plus 19 squared plus 25, yeah, 25 squared plus 8 squared equals 3078. I'm going to divide that by 3 equals 1000. So this number here is 1026. 1026 is what this whole thing sort of adds up to, right? This part. Okay, so let's take 1026 minus 889.556 minus 888 plus 855.704 equals, so this whole thing equals, I got 104. So again, this is right, but let's say this is 104.148, okay? Or round up to 15. Okay, so far these are lining up very nicely with all of the sum of squares from before. I'm going to write those components down really fast, so we lose on the next page in case we have to. So A is 889.556. For B, it's 888. AB is 1026, and for the part that corresponds to T is 855.704. Alright, just so I don't have to go back and forth between the two. Okay, just a couple pieces here left on the computational approach where we, figured out some other stuff before, and I just sort of captured this stuff over just to make sure. But all that's left is to figure out the sum of squares within groups, sum of squares total, and those are pretty easy since we already found most of the stuff. So you notice I wrote out the sum of AJ, the sum of AJ square, AJ BK squared over, and I wrote this out, and I sort of gave myself a space here, but I don't need to do this, right? This I already did. I already figured out is this this 1027 here. I'm reading 1027, reading 1026 and saying 1027 is 1026. Okay, so I can figure out my sum of y squared is already given to me up here, 1046. So 1046 minus 1026 is 20. That's it. Again, I also have sum of y squared there. So again, this is going to be 1046 here. But this is the t squared over ABN. Well, I don't need to do that. I already did it. I already know that t is 855.704, which is what I have there, right? So I subtract the 2 and I get to 190.3. So it ends up being a lot easier because I don't, the parts keep sort of getting recycled and reused as you go further down. So now we have, we've gone through all the sum of squares through the computational approach.